So those who have not used this, so this is another way of reading a character, and probably this is another possible way of doing things. Are you getting the options? Sorry. Are the options clear? So this is one option of reading a character input. This is another option, and this is another option. Now in the first case, what it gets translated to? It gets translated to scene dot operator Okay, so this will be the call. So scene is the object which invokes this method and reads the and this we pass this C and somehow we read it, right? In the second case, what is the method called? Which method is called to read the input?
Get.
And which object invokes?
Scene.
So scene is the object and this is the method invoked, as we have found. So if I know the object name to be A and if the method name is fn, so this is how we invoke a particular member method of a class whose instance is A, right? Now, can you see some feature of object-oriented programming that gets illustrated here in these two statements? Sorry, this
Yes,
should
sir.
be right. So this should be C. So what is this? So these are the three options, like option 1, option 2, and option 3. With option 2 and 3, which particular feature of object-oriented programming gets illustrated?
Polymorphism.
So what is this? So what is the name of the method? Name of the method is get, right? So in this case, the object scene is invoking a copy of get which accepts what? What is the data type that it accepts as input?
Void.
Void. But it returns the value that it has read and assigns it to C. But in the other option, the third option, the method is still the get which accepts the character itself as input and returns void. Are you getting the difference?
Yes, sir.
So this is again an example that the get method, it has got two versions, or you can say it has got two interfaces. In the second one, in this one, it accepts void and returns the value that it has actually read, and then you assign it to C. In the third option, it's a different way of the same thing you read, but in a different, by invoking another say copy of get, another prototype of get which directly takes the character. So this is the case. So if this is the character variable, so these are the different ways. So that was the illustration of how the different features of C++ or object-oriented programming, we start using it right from the very simple C++ code. Okay, so in this class, we'll be switching to some more advantages in terms of writing C++ codes, and one of them is dealing with dynamic memory allocation. Okay, so one advantage this time is I have already covered the pointers in C. I think all of you can recall those basic concepts of pointers. What is a pointer? What is a say pointer to integer? What is a pointer to integer? What is the implication of the base address of a 2D array, 1D array, and all this? What is the association of pointers and constants, right? So can you all recall some of those concepts?
Yes, sir.
Yes, sir.
Yes.
And also we have talked extensively about the dynamic memory allocation, where we allocated dynamically the space for a one-dimensional array, for a two-dimensional array, for a three-dimensional array, and all this, right? And in that C dynamic memory allocation, what are the functions that we have used?
Malloc and
Malloc.
free.
So it was mostly we used malloc for allocation and free for
Allocation.
deallocation. And there is one more, there are two more things that we also discussed. One is the function pointer. Can you recall what is function pointer, and did I discuss that there? Function
Okay.
pointer in your third semester?
So couldn't recall. I mean, can
Okay.
you?
Okay, anyway, so we'll do it here, maybe sometime later, so that can be done. But I think you can all recall the memory allocation, right? So what type of variable is allocated? So a memory is a primary memory associated with a program or a process which is running. A program that which is running is called a process. So the contents of memory that it requires for execution is organized in four segments: those stack segment, heap segment, data segment, and uh, code segment. So I think that those parts you can recall, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
And the heap segment, actually, whenever you go for dynamic allocation, things are getting allocated from the heap segment. If we declare anything as global or static, global variable or static variable, those will be allocated space from the which segment?
Stack
No, global
data segment.
data segment. So global and static, these are all gets they all get space from the data segment, maybe called as DS. The code, the object code, or the functions, the object code of the functions, individual functions and all, these are all stored in the
Code segment.
Text.
yes, text segment or code segment, whatever you say, it is CS. And the dynamic allocated space, we get it from the
Heap.
heap segment HS. And finally, all the local variables, non-static local variables, they are allocated space from the.
Stack.
Stack.
So those things you can all recall, right? So in this particular C++ course, at least we don't have to discuss all about those details, and we know that using the size of, we can figure out that how much of space a particular pointer variable requires. And we also found that any type of pointer variable, so to store addresses of integers, float, character, we have to declare a specific pointer type, right? So integer pointer for storing address of integers, float pointers to store addresses of float, and all this like that. But any pointer variable type, no matter what type of entity it points to, they will all require the same amount of space, right? Is that fine?
Yes, sir.
So if it is an
Yes,
integer
sir.
pointer, or if it is an integer pointer, or if it is an integer pointer, so all will require just 4 bytes, depending on the compiler, or maybe 2 bytes. So, but that will all be the same. And it is also true that without typecasting, you probably cannot store the address of an integer pointer to integer to a pointer to integer. So when you when you say copy the contents of one pointer variable to the other, the both sides must be compatible. But sometimes if it is in void, so if the pointer type is void type, then if we require, we can typecast it to a suitable type, and that in malloc we usually do that, right? So in this particular uh, semester, we'll be mainly focusing in how this runtime allocation or dynamic allocation is done in C++. And mostly we'll be talking about some replacements of malloc and free. So instead of malloc and free, we'll be using something. So what is that? What is the what is that we use instead of malloc?
New.
New.
New. So we learn that, and instead of free,
Delete.
Delete.
delete. So these two things will learn, and then the best thing is just to practice all those type of allocations, a two-dimensional array allocation with known number of rows and columns, with known number of rows but unknown number of columns, and vice versa. And all these we can rewrite using this new and delete. So just replacing the malloc and calloc, malloc and free, will be rewriting this to just to know that how this is done here, because the basic concepts are already there. So let us so I think this is feasible. So instead of calloc, malloc, and free, we'll be using new and delete. So what is new and delete? Uh, what is the basic difference? What is malloc, calloc, and free? What are those?
Library functions.
These are library functions. So this is these are functions. But can you see the difference? New and delete. What are those?
Operators.
So have you ever seen an operator which is which is like a keyword like new and delete? So which is like an English type word? Till now, have you ever seen in C an operator which looks like something like this? Uh, that appears like words?
No, sir.
Operators are usually symbols, like so the symbols that is there in the keyboard, plus, minus, then arrow, or say shift, question mark, and all this. But this new and delete, although they look like keywords, but these are actually operators. Okay, so that is something strange, and for the first time it seems that how this can be an operator, but these are operators, and it will so okay, we'll come to the advantage of that, but let us now gradually look into it. What is the syntax of using this operator? So first thing is, new and delete are not functions like malloc and free. That's the first thing to know. So these are operators. So this you should notice right from the beginning. So in C++, we have got new and delete for dynamic memory allocation in addition to malloc. So because C++ is compatible to C, so you can try things using malloc, calloc, and all this, but you can do it using new and delete also. So now let us come to the point. So if I would like to replace this one using new, so what do I need to write? So first thing is I have to
Int star
I'm
p.
creating a int asterisk p, that's a pointer, and I would like to, so what is the purpose of this? What was the intention here? Malloc size
To
of int. So
point
how
to
much
the
space I am allocating here dynamically?
Size of an integer.
So I would like to allocate dynamically the size of a single integer, one integer space. That will be allocated from the heap, and the base address of that entire block will be typecasted to integer type because malloc is void, and it will be assigned to this integer pointer variable p, right? So how do I write this here?
new int parenthesis
New int and then
parenthesis
parenthesis. Which one? This one or this one?
so first one.
And what else? Anybody else? What do I write? This much. You just require
So square braces.
this much. Okay, this is enough. New int, that's all. So these two are equivalent. So if you know what this was, you know that what this is going to do for you. Okay, so what I need to mention here is, so new means I would like I'm requesting a dynamic allocation for allocating one integer object. So that is the case. And the base address, whatever it is returned, it will be assigned to P. So can you see the advantages here? What are the advantages over malloc?
We don't need to specify like size of int, and typecasting is also not here.
So I think all others, they can also see it. So the size of int, you don't have to specify the size of int, how much size you require. Rather, you just, if you specify just int, it knows that what is the size of int and it will automatically do it on your behalf, this new operator. At the same time, you don't have to even typecast it back to, so that it was returning void type, converted to integer type, integer pointer type. So all these are automatically done in abstract way, and you just write new means I would like to allocate dynamically some space for a single integer variable. That's all. Is that fine? So now,
Yes, sir.
can you focus on the second one, the second point in the C code here? Now the second thing is, now what we do here, we do the same, and then we initialize the allocated space for one integer to value 5. Is the purpose clear?
Yes, sir.
So if I would like to do it using new, what should I do?
Sir, new
Add
int
a parenthesis and
and
inside 5.
inside 5.
So this was enough to allocate space for a single integer, say object. Now if I would like to do the initialization, I can just write here this much. Got the difference?
Yes, sir.
So now you have one more advantage. What is that? Using new over malloc.
We can initialize it in that
If you
statement.
want, you can leave it uninitialized. If you want, you can initialize it also, the object that you are allocating, right? So the object will be allocated space from the heap segment, and at the same time, while it is allocating the space, it will be initializing the state of the object. That means if it is an integer, it's fine, but if it is, it may be, say, it's an employee object, and the employee is having his name, ID, phone number, and all this. So if I talk in terms of object-oriented programming, so if employee is a class and E is a employee object, so you can pass on the initial value of the attributes of that employee object. So it will be done. Okay. So in a single statement, so you don't have to use two statements for that. In C also it can be done, but it need actually two statements. But it can be done in a more compact form. Now, what is the equivalent of this one? What is the intention of this? So we are going to allocate
Float.
a space for a floating point variable, one single floating point object or variable we are allocating, and we are assigning it to Q, and then we are initializing it. So what will be the equivalent here?
Float pointer p equals to new float 5.8.
Again, you give this and write here 5.8. Is that okay?
Yes, sir.
So the only change is here. So just mention what is the type of the object which you would like to allocate. And if you would like to initialize, you do it, or otherwise you just leave it. Now focus on this one. What is the purpose?
To allocate memory for n integers.
N integer. So size of int into n. So that means I am trying to, instead of just allocating the space for a single integer, I would like to, I'm requesting the allocation for multiple block of integers. In this case, right? A set of integers. So this probably denotes the the allocation of dynamic allocation of a single one-dimensional array. So I just, instead of 1, so size of int multiplied by 7, that can be done. So here if you would like to do it using this new operator, then what I would like to do,
New int and n in
Third
square
bracket.
brackets.
Third bracket. Square brackets.
say for example it is say 4. Okay. Let it be n. So got the difference with the previous and this one?
Yes, sir.
So the
Yes.
difference is in terms of using the parentheses. So in the when you initialize a single object, you basically use this type of parentheses. When you go for a block allocation, you go for this type of parentheses. So it's allocation of a collection of objects. And this is meant for initialize a single object. Okay. So now we talk about deallocation of memory. So deallocation, what we know in C, we write it as free P. So what will be the equivalent here?
Delete p if it is a single int.
So delete P. So what is the purpose of delete P?
To deallocate the memory p is pointing to.
So here this means if this is say P, a pointer variable P, okay, which is pointing to this amount of space. So this delete P, if we perform this delete P, what do you expect? Which one gets deleted?
Heap.
The address it is pointing to. The first part only.
If we write it in, so if we draw it in blue. So which parts gets deleted? What is the expectation? Those who don't know C++, what do you think? What should be done?
Heap part will delete it, sir.
Yeah, so do you expect the whole thing to be deleted?
No, sir.
No, I mean those who do not know C++, what do you expect? If I write delete P, P is pointing to this. So do you expect the whole thing to be deleted? That is normal because free P also deletes the whole stuff, right? So this entire part is in the heap, right? So delete P, which part it will deallocate? It will actually deallocate only the first element of that block. Okay, so this is what it means. And if I would like to deallocate the entire block of space by calling delete operator, what do I need to write?
Delete third brackets p.
Sorry. So what this does, So you can so this means if this is say P and this is the space it is pointing to towards, so this means it will delete the whole of this space. So got the difference? And here it is deleting only the first element. So have you got the difference between these two? The use of delete?
Yes, sir.
So if I, in true sense, if I say that this free P, so which one is equivalent to this free P that we understand the impact of free P in C? Which of these two? This the first or second one?
The second one.
Second one.
Second one.
So this is equivalent to this, but this is probably there is nothing such thing. Something like the first one in free while we use free. So free, if you give the base address right from that point, anything that is there allocated as a chunk will be deallocated. So when we are deleting, when we are calling delete new operator, we should be cautious about to write whether it is delete P or delete this parenthesis with P. That means it will deallocate the contiguous block space pointed by that is starting from the address stored in P. Okay. So the first thing is so there are lots of advantages, right? What are the advantages of using new and delete?
Don't have to use extra library function.
Hmm?
You don't have to include any other library. It is on the IO stream itself.
Yes, that is there in malloc and calloc also. I mean, this is a part of std.h and all this. So that is there. So sometimes you have to, so some header files you have to definitely include. But the advantage is, as you can see, we can initialize also simultaneously. We don't have to specify the size of the object explicitly, or we don't have to typecast explicitly. That is the advantage. We have the flexibility to initialize a single object when it is allocated. We can go for block allocation in both the cases, and the deletion, it has got two versions. Okay. So there is another advantage, that is the adaptiveness. That is there always. We can extend the notion in contradiction to that we have done in C. So what it means, so in C, if you have got say integer so sorry, if it is a again I take the example of a matrix. So what is this? What does it mean? M is a pointer to a matrix class or matrix object, right? Matrix data types. Say we have defined it. Now, if I would like to write something like this, malloc size of M and then matrix this. So the point is size of M. So it becomes difficult. So the malloc actually works for size of int, size of float, and all this. And if you would like to uh, extend malloc for user defined data types, for new data types, it becomes complicated and it is not possible. Okay. So in this case, uh, because it's an operator, see, this is an operator. So operators can be overloaded, right? Any operators can be overloaded. So these new and delete operators also can be overloaded. So the idea is we can think of writing a matrix class and have something like this. Got it?
Yes, sir.
Now what happens? So this new was an operator which was overloaded for allocating space for an integer object, for a float object, for some other type of objects, but it can also be made, it can also be forced to be overloaded so that it can allocate a matrix object, which is a user defined, a new class that a user defines. Is that fine? And at the same time, if you write delete m, so it can deallocate that matrix object also in a proper way. So the thing is, this new and delete, these operators can be overloaded for new user defined class types or abstract data types, whatever you say. Is that fine?
Yes, sir.
So for that, what we have to do as C++ programmers, when we implement the matrix class, when we define the details of the matrix class, we have to add, for overloading an operator, what we need to add? Corresponding to any overloaded operator, there should be a corresponding operator special function, which is called the operator function, right? We'll see the details of it. So the thing is, in that matrix class definition, you should have a method which is a special kind of method, special kind of function for overloading this new and for overloading this delete in a suitable way, so that these or such calls or such statements becomes valid. Okay. So what happens? So these also, as you can see, this such codes are also looking more and more compact, and it is also adaptive. So the advantages are, so advantages of new and delete. So these are the highlights. So initialization during allocation, size of element not required, and typecasting not required. Two options of using the delete operator for deleting a single element, the first element, the first object in an array of objects, or it can be the entire block of objects. So both are possible. And then new and delete, sorry, and the new and delete operators may be overloaded for user defined classes like stack or matrix, whatever. So here the new, so here the new operator has been overloaded for the stack class. Here the new operator has been overloaded for the matrix class. Okay, so these are the advantages, and therefore from now onwards, while we go for dynamic allocation, we are not going to use malloc or free or calloc. Okay. Okay, so any question till this point? This is pretty simple. So hello.
Yes, sir.
Okay, so now let us just revise all those points. Dynamic allocation of a one-dimensional array. So can you see the change? So the earlier we used to write here typecasting, malloc, and all this. So can you see the simple change here? Just a minute. Hello. Okay, so here you can see that this is the only change. So the rest of the code remains unchanged, all the declaration and all this. So again, when you do this, right, instead of, so this becomes very simple, new int p n. So what we are doing here, it's a one-dimensional array of size n, 1D array of size n, integer type array. And once we have done, now in the during discussion about pointers also, we found that no matter how you allocate the space, it may be a static allocation or it may be a dynamic allocation, but the notation of accessing the elements pi, you can write either this or you can write what is the equivalent. So this is the index notation. What is the pointer notation here?
Star of p plus I.
So star of p plus I. So both are possible. So pi and star of p plus I are equivalent, even in case of new delete also. Okay. And say once we have done something like this, so if I write here delete p, that means what? I am trying to delete the entire block of space pointed by p. So instead of free, we have used this. So these are the only two changes that we have made in that previous code that we have done. So this is simple. And you see, apart from iostream.h, nothing else need to be included as a header file. Okay, so here, can you read this? So int, so how I read the first one? So this is a static allocation of one-dimensional array of 5 integer elements. Okay, what is the second one? How do I read this? What is the purpose?
An array of size 5 of constant integers.
So the
And
elements
initial
are
values.
constant integers. So this array actually contains the elements, each of which are treated as constants, right? So we have initialized it, because whenever you are writing a constant, you have to initialize it. So 25961, once you have assigned, you cannot change the contents of it. So you here you cannot write say a2 plus plus, you cannot do, because the elements of the array is a constant. It's basically a constant integer array, you can say. It's a one-dimensional static allocation of one-dimensional constant integer array. Is that fine?
Yes, sir.
So what is the next one? So this we just now mentioned. So it's a dynamic allocation of a single. One means a single integer element. Now what about the second one? This one?
Dynamic allocation of a single constant integer.
See, focus on the parentheses here. So once we give the parentheses, what does it mean? So this is
We are
allocation of
initializing.
just one element, but I am forcing the initialization there itself during allocation. So here, but what does this mean?
It is constant
Dynamic
integer.
allocation of array of.
Yeah, so this is not an array. Dynamic allocation of what? Dynamic allocation of a single constant integer. Getting the point? Can you say that? This is a dynamic allocation of a single, because this 2 is initialized. So initialization value. Dynamic allocation of a single constant integer. Because the element that I allocate, where from it gets allocation? The space. Where from the space of allocation, from which segment it is obtained from?
Heap.
Heap. And from in which segment P is getting the space from? If it is declared within main.
Stack.
So P is allocated in the stack. It's a static allocation. But whatever P points to, that is in the heap segment. And and the contents of that location pointed by P should be treated as a constant. Is that part clear?
Yes, sir.
Yes, sir.
So because it's a constant, you have to initialize, and that is how you achieve it here. So here, which one will be not allowed? Which of these two will not be allowed? P plus plus
Star
and
P
asterisk
plus
plus.
plus.
So asterisk,
Second
so
one.
because whatever P points to, so the object which P points to will be treated as a constant. So the thing is, you cannot, uh, uh, if you want, you can make P point to something else. Okay. So P can point to something else. So P plus plus means P will be pointing to the next object in that sequence. So P can point to anything at any point of time, but the contents that P was pointing to, you cannot change it. This means asterisk P means the contents of what P points to, you are trying to change it. That is not possible. But this is possible. Is that part clear to all of you?
Yes, sir.
So it's clear to all of you. So what is the implication of this one? Focus on this.
Dynamic allocation of 1D array of two integers.
There is no constant associated, so it's just one dimensional integer array, right, of size 2, integer array of size 2. That's all. Okay, and what about this one?
One D array of integer pointers.
So why it is 1D? Because this one, it says that it is a one, so it's a one dimensional, or it's a collection of. So what is this? What is your intention? Your intention is to allocate space. Your intention is to allocate space for what? What you
Integer
want?
pointers.
So this is the objects. So this is the object here. So earlier you wanted to allocate space for integer objects, two integer objects. This is just a single integer object. This is also a single integer object. But here what you want, new, you call new to allocate space for what? This is what you want to be allocated. What is this? This is a
Integer pointer.
integer pointer. So you are asking to allocate integer pointers. How many? Because of the third bracket,
2.
knows that you require two such integer objects. Okay, so this is what it means. So you are requesting the allocation of space for two objects, and each of which are integer pointers, and the base address of that, this one, is actually allocated to P. So P is pointing to this one. Is that fine?
Yes, sir.
So anything that points to an integer pointer, how that variable should be declared? It must be declared as a pointer to integer pointer, right? So P should be declared to be a pointer to integer pointer, because P is storing the address of integer pointers. So that's why it is int asterisk asterisk P. Can you recall this?
Yes, sir.
The rest of the class?
Yes, sir.
And what about this one? New is called to allocate space for what kind of object?
Pointer to float pointer.
So asterisk, so pointer to float. These type of objects. And how many of them? 3 of them. Okay, so this is the case. Say maybe that this is the array. So this is the dynamic allocation, the space for dynamic allocation that you are requesting. So requesting for this, and they are what? They are float asterisk asterisk. They are pointer to float. So this you have requested for, so that each of them they can store the address of a 2D array, because this means so maybe this is pointing to this 2-dimensional array, this is pointing to this 2-dimensional array, this is pointing to this 2-dimensional array, like this. And this q is another pointer. You see, this is a pointer which should be capable of storing the base address of this entire block, right? So q should be able to store the address of this type of object, float asterisk asterisk, because this type of object. So q should be a pointer to float asterisk asterisk. That's why there are 3 asterisks. Is that okay?
Yes, sir.
So how do I read it? Dynamic allocation of a 1D array. It's a 1D array of float pointer objects of size 3. Okay. So now till now what we are discussing about is the dynamic allocation of 1D arrays only. So now let us switch to the 2D arrays. 2D arrays also the basics we already know. So we just have to recap. So up to that part, are there any doubts? So let us come to these 2D arrays. So 2D arrays, a 2D array is designated by the number of rows and the number of columns, right? So now there can be 4 cases that we discussed last time also while discussing dynamic allocation of 2D arrays. The first case is R is known and C is known. So if both the dimensions are known, we definitely do not go for dynamic allocation. It is enough to have static allocation, because you know the exact requirement of the size, so you go for static allocation. That is trivial. But in case you do not know, neither R nor C, so both are unknown, the number of rows and the number of columns. So this can be the case 2. You know the number of rows, but you do not know number of columns. Okay. So here you know the number of rows. So this size you know, but you do not know how many columns will be there, right? This is not known. And in this case, so in this particular case, the number of rows are unknown. So this you do not know, but you know the number of columns are fixed. So the number of columns are known, but you don't know how many rows are there. And this is the case where both are unknown. So you do not know this one, you do not know this one. And this one is the last one. What is the case? R is known and C is different for different rows. So this you know how many rows are there, but this is different. So this is this much, this is this much. So all these we have, I think you have solved already in C. So see, it's something like this. But this R is fixed. But the C varies. Number of columns varies for each row. So these are the possible cases in a 2-dimensional allocation, 2-dimensional array allocation. Can you recall this?
Yes, sir.
Yes, sir.
Now, let us take the second case where both are unknown. That's a most generic case, I mean the most general scenario. Both are unknown. So we already know that if I so if I try something like this, will it work? So what do I need to write? New int. So a 2D array of R rows and C columns. R rows and C columns. So in the new operator, what do I need to pass? New. If I have to allocate space for multiple objects, I have to pass on the size of it. I have to specify the size. So if I specify the size as R times C, because that is the total size of the objects, and if I call new, it will not work, right? Have we ever tried this? In C++, did you ever try to allocate two-dimensional arrays using new? Any of you? Did you try earlier? Hello?
Yes, sir. Not tried
Yes.
this one.
Yes, some of you have tried. Yeah, using new allocating 2D arrays. Have you who has done?
Yes, sir. I have done.
Yeah, so how we have done?
Sir, at first we have to allocate an integer pointer array of size r, and then we have to in a loop we have to traverse through r and then allocate for each row one integer array.
So that was what we have done exactly in C, right?
Yes.
Yes, sir.
So in C, can you all recall? We have already discussed that, right? So we have already done in that way the 2D allocation of a 2D array. I think I hope that everybody of you have tried and done it. All the assignments that I have given using metrics and all.
Yes,
Yes,
sir.
sir.
So the point that I want to make is using new also. There is no shortcut here. So you expect that new is seems to be too intelligent that you don't have to pass the size of the object, you don't have to typecast it and all this. But new is not so intelligent that it knows that this r times c, this entire space. So this space means maybe a space of say if it is say r equals to 3, if r equals to 3 and c equals to 4, that means total it requires 3 into 4, 12 objects, maybe integer objects. So if this is, if you ask new to allocate space for 12 integer objects, it can definitely do it, but it does not know how you are going to organize it to store a 2D array. So there can be many options. So it can be as a 3 cross 4. It can be also, you can decide to use it as a 1 cross 12. So just one so it is just like one column and 12 rows, or it can be 4 rows and 3 columns, or it may be 6 rows and 2 columns. So what is your intention? The space requirement for 12 objects, it is fine, it is known, but how you are going to use it, either this or this or this or this cannot be. So this, the new cannot know your intention, your hidden intention. So that's why new fails to allocate uh, this one, because you see in the new there is no provision to say specify r and c separately. What you are passing here is just uh, the product of r and c, right? Is that part clear?
Yes,
Yes,
sir.
sir.
And there is no such provision, so new is not that intelligent. So you have to again get back to the same process of allocating a, uh array of integer pointers of size r, and which then and then you have to use another loop that will allocate. So it will be allocating the space for this one, all the row pointers. This is an integer asterisk, and then you have to go on allocating each column space for space for each row corresponding to the same number of columns that they have. And each time you do it, you assign the base address here, so it will be allocating pointing to this. So all the same previous stuff. Okay, and then basically this the pointer that will be pointing to this, say p, because this is integer pointer, it should be a pointer to integer, right?
Sir,
Yes, sir.
excuse me, but you asked me to remind you at 3:45.
Yeah, that's good.
Uh,
Yeah, fine. Yeah, I really asked him to do that. I'll wrap it up within 15 minutes. So you give one more alert at right at 4, right? Okay.
Okay, sir.
Okay. So what? So now can you write it in terms of new? Can you write this?
So
So
you have
new,
to write new int star.
Okay. So let us write it here. So first of all, I have to declare p as integer pointer to pointer, right? That is for sure, because p is actually pointing to integer pointers. So that is fine, this part. So first thing I have to do this a. Say a means this allocation. This is dynamic allocation. And then I have to, in a loop, I have to go for this b part allocation. So what is the a part allocation? So whatever I allocate here in the part a should be assigned to p. So p should be assigned to what? So how do I specify this allocation?
so new integer pointer.
New. What I'm allocating here, what are the elements?
Integer pointer.
Integer pointer.
How many of them?
Third square bracket. Size
How many of them?
R.
R times C.
Right? So let us assume that we have got R and C also declared and also read it properly. C in R and C. This is there. Okay. So this is the part A. So now to go for part B. So part B, what do I do?
So using a for loop.
So you have a for loop, and I declare the integer, the index, that counter variable here itself 0, I less than, what is this? What should be the case? How many I am trying to allocate here? All, each of the R rows, each of the
Yes, sir.
R rows that I allocate. And what is the allocation step? And whatever I allocate, the ith row, the allocation of the ith row, say for example, this one should be allocated. The base address, whatever we obtain after allocation, should be assigned to P of I, right?
Yes,
So
sir.
what do I write here? P of I should store what? So what is the allocation? How to allocate this one?
New int.
C.
So what are these objects?
These are integers.
Integer.
So these are simple integers. So we are allocating basically integers using new. But how many of them?
C.
C.
Square bracket.
Is always C. As this was always, this was R, this was already C. So this is C. And this is as a block of C integers. Okay. So this is a part B, right? So the point to note is, even in new, there is no shortcut. You have to do it in a proper way, in an indirect way. And when you go for deallocation, what do I do? So this is allocation part. So if I write a deallocation, what do I need to do?
Loop through. First use a for loop to deallocate all the columns.
So this is a deallocation. Okay. So first of all, as we have done, we have to deallocate first the rows. That means the B part. So it's like first you do B dashed and then you followed by A dashed. Means deallocate the portions of B and then. So how do I do this B? Again, I have to do
Loop
it
through A.
one by one. So it's the for loop again. The same I can use here. I less than how many of them? R number of rows. Each of them I would like to deallocate. And what should be the step? The ith row, how I
Delete.
deallocate? Delete.
Yes.
Delete.
Square
PI.
brackets.
I,
But you have to write here, right? Because so PI means if I just write delete PI, it will deallocate only this much.
first
But
element.
if I would like to deallocate the whole thing, I have to write this square bracket, then PI. Is that fine?
Yes, sir.
So this is the deallocation of the entire row. Now once this is done, so one by one, this should be off, this should be off, like this for loop. Now all these are deallocated completely from the heap. Now there is no more the requirement of this array which actually stores all the base addresses, right? So this is also not required. So I can do it in just one shot. So what should I do now? How to deallocate this one, this part A?
So delete square bracket pointer P.
So just writing P, because P points to the base address. If I write here this parenthesis, that means this entire set of space starting from P will be deallocated. So this is within the for loop and this is outside the for loop. This delete P is outside the for loop. Is that part clear?
Yes, sir.
So this was the allocation and this was the deallocation. So this again, these are some revisions. Only we just rewrite the whole thing, whole stuff in terms of new and delete. That's all. So these are pretty simple things. And you, so this is the kind of error that you would like you'd encounter if you just write int then r multiplied c. Okay, so these parts we have already done. This is what it means, and I think we have already explained these things. So this is what it is, A and B. Okay, so now this we really know that how in which sequence it works and all. The second one is R is known, C is unknown. Can we do this? R is known and C is unknown. So if this is known, if this R part is known, that means this can be done static, right? So in analogy to the previous one, so the A portion can be done in a static way, allocation. Can you recall that? I say that R is known. R is known means this allocation that we discussed earlier. So this part can be done without dynamic allocation, right? Because we know the value of R. So here, so this part will be done statically. So how to do it? Then so this is how can we do this? That means we are trying to allocate statically integer pointer array. An array, one-dimensional array, is a one-dimensional array of fixed size R. That's why I specify directly, whose elements are of type integer pointer. So that was the equivalent to that part A, which is now static. But once we have done that, the rest of the part B, should again be like that, like AI equals to new int C. Each need to be done separately. This, then this, then this, and each time The addresses are stored here. Is that fine?
Yes, sir.
Yes, sir.
So here, which portion was stored in heap and which portion was stored in the stack segment, heap
A
segment?
is A is stored in the stack.
So this entire array, so this is entirely stored in the stack segment, right? This is in the stack segment. And these portions, these chunks of space, which stores a row for each row, that is stored in the heap segment, right?
Yes, sir.
Yes, sir.
Earlier it was in the previous case 2, it was the p, the single variable p, which is a pointer to integer, was in the stack, but the entirely the rest of the allocation, both A and part B, they are all in the heap. Now because this part is static and if this is done within some function, so this part will be in the stack segment, but these parts will be in the heap segment. So what about so this is what is done. This is the static part, this is the dynamic part. So what about this one? R is known but C is unknown. Can you see the case? R is unknown but C is known. So you know how many the size of each rows. The size of each rows are known. They are fixed and known. Say I need so probably I need each row to be of size 5 elements. But how many rows do I need? I do not know. That should be done. That should be inputted in when you start the program running, right? So here C is 2, say for example, but R is unknown. So you read basically the value of R, and then what should be the declaration of the pointer? Can you see the difference? Can you see the difference of how to define P? Can you recall it from our C class, C pointers? Only 3 minutes are left.
Yes, sir.
So Famsi will put an alarm again and raise an alarm. So before that, let us finish. So what is this? What was that? So this P.
P.
So P is a. So how do I read this? So earlier, so if I give a parenthesis here, this means P is a pointer. That's all. P is a pointer variable capable of pointing to an one-dimensional array of elements of size 2. So this is a pointer which is capable of pointing to any element of size 2 integers. Is that fine? Can you recall this?
Yes, sir.
Yes, sir.
Yes, sir.
So that is what we know, what you needed. And then if you write this one, this statement, what does it mean? New int R and C. Now you see the difference that if you are mentioning R and C separately. Okay, so here you mention the number of rows. So in a single shot, you can make the allocation, because now you know that these are the basic elements. These are the basic elements. So how many of such elements are number of elements? Okay.
Yes, sir.
So in this case, P is again in the stack segment, and the rest of the entire allocation goes in the heap. So P0 is pointing to the first row, P1 is a sub, but the thing is there's a lesser storage space required. We don't have to have an explicit 1D array of integer pointers storing this. Got the difference?
Yes, sir.
So try this of your own to make yourself convinced that this way it works. Can you see this? The code here? I'll share the codes. So this is how it works. So in a single statement, you can do the allocation, dynamic allocation, where the number of columns are all fixed, but the number of rows are changed. Okay. And this is the last one where you have got variable number of columns in each row. So this is the one that marks processing, I think the assignment that I gave, where you can just do the part A and then do the part A, and in the B, you can just write here, because that is variable, you have got one more integer element to store the number of elements in a row. So that's why it is C plus 1, and you specify the value of C. So C actually changes. So you read the value of C and then you allocate the space. So is that clear?
Yes, sir.
Yes, sir.
So this is basically the part B. Okay. Okay, so that's the end of this class. So this is a summary. So this actually calculates the space requirement. So this space requirement is R into C into 4, because it's just all static. So you just have to allocate the space for the elements. But in this case, you have to allocate the space for this the P, that requires 2 bytes for this 1D array of integer pointers, that is R into 4. And then for each of the rows, you have to R into C into 4. So this is the total space requirement. So it requires more space. Then this one, this is R into 4. This is all static, plus this one. So it is 2 bytes or maybe 4 bytes less than this one, the third option. And the fourth option, it just requires the space for this pointer plus R into C into 4. Okay, you check it, and if you have got any queries, I'll share the slides. You can ask me. Okay, so that's the end. So the assignment set 2 will be just a repetition of those that you have done in probably in C, matrix multiplication, determinant. So just try using new and delete. Just copy those codes, replace those malloc and delete free statements, and just submit it. So you know that you are familiar with the use of new and delete. Okay. So in the next class, we'll start the reference type variable. So
Sir,
reference is a new data type that is or a new type of feature that is supported in C++ or in also in Java and all this, all the object-oriented programming. So what is the use of reference? Why we need that? And what is the what are the situations where it is essential? That we'll see in the next class. And once that part is done, I think the basics of probably the non-object oriented features are done. And then Deepanita, she will start discussing about the how we declare classes, how we declare objects, how the object, so all the finer details she will start. And then once she completes, and then constructor, destructor, and all those basic things. So once she completes it, I'll then again resume from function overloading, operator overloading, that portion, mostly the polymorphism, that part. And we'll have a few more things to also learn regarding static objects, static member functions, and all this. So maybe after 2 weeks of our classes, I'll again resume. And then as per the plans, she will then start the inheritance part, and I'll do the virtual functions, that type of polymorphism.
yes, sir.
Runtime polymorphism. Okay. And then finally there will be exception handling, that part I'll do. And then finally the STL, standard template library. Okay, any more questions?
Sir, sir, in an allocated array, if we delete any of the middle element using delete without square braces, then what will happen?
What will happen means you're basically splitting the entire chunk, the entire contiguous space that you have allocated. So you have deallocated one particular element of that. So it basically gets divided into two parts. So generally we do not do that, but if you do, so that will be, so it's up to you that it has been done.
If we do that, then can we again allocate? We cannot do that, no? We cannot
See, as I
reallocate.
mentioned, so the basic thing that you should understand, this allocation, who does the allocation, who satisfies your allocation requests, or who actually takes your requests that you make by calling new or malloc, which part of the computing system takes your calls, I mean such requests, which part of a computer deals with such requests. So if I make a request
system.
to it's operating system.
Operating system. Yes.
And operating system is a more generic. So which module of the operating system does it? Memory management module, CPU management module, file management module. So which part? Memory management module.
Management.
Right? And memory management, when it is done, so it is again, it is, if it is like a say hotel manager, memory manager is operating system memory manager is like a hotel manager in a hotel. So when you ask for the manager, say you got a block allocation of 10 students, right? You got allocation, you went for a summer vacation, 10 students, each of them booked a room, and then maybe the fifth student in that row, he wants to leave for some reasons. So he says that, okay, I would like to surrender my room and I'm leaving. Okay, so he checks out. Now again, if you go to the manager and ask that, okay, one more friend is coming, so is it guaranteed that the manager will be able to allocate the same room that your friend just now checked out?
No, sir.
No, sir.
So there is no guarantee, because in between, before you have just made a made the request, maybe because of online reservations, somebody else has booked the same room that your friend just now reallocated or checked out. So there is no guarantee. So if you ask the manager that if I check out, will you give me the same room? He says that no, there is no guarantee. You can do that. Let us see. So that you will get, if you just go for a new allocation of a new int, will you get the same? Nobody knows. So where from? So where is the logic? Because the memory manager also keeps track of uh, the holes. Hole means those free spaces. So those small pieces of free unallocated spaces, it somehow need to have another data structure to keep track of all those scattered holes or unallocated spaces, right? And there are different data structures for that, buddy lists and all this. We can discuss few of them. Maybe buddy list, we can I can give an assignment on that. So there is another logic for that, how the allocation will be done and how the free space will be managed, what kind of data structure it uses. So keeping all that in mind, when you know all those, you can be sure that, okay, there is no guarantee, but it may be that the same is again allocated, but there is no guarantee on that. And now the worst thing that happens, earlier it was a single chunk of say 10 objects, so one pointer was enough. Now once you have split it into two small chunks, two contiguous chunks, so you have to now we have to require two pointers to keep track, because it got split into two parts, right?
Yes, sir.
So you basically complicating the whole thing. If you really want to have one of your friend gets deallocated, so before you do that, you basically shift the, so because you are treating it in an array, so array, what happens, so the rest of the elements will be shifted one place to fill up that, so that you still have a contiguous chunk of space. So that is probably what you would like to have. And if you think that again this becomes too often shifting is done, so then you know the solution. What is the solution? You don't go for an array allocation, you basically go for a linked allocation or a linked list kind of thing, because of this problem that contiguous chunk gets broken into pieces once you deallocate some element. Okay, is there any other question? Okay, so I'll be sharing these slides and also the, I think I've not shown any codes, but those simple codes I'll also share using new and it. And the assignments, I'll provide you the assignments. There is one discussion that probably I'll make on writing or generating pseudo random numbers. So random number, I have forwarded you the reading stuff and the wiki link. So better I would ask you to go through it, have a self study, and then we can have a small discussion on that, how to generate random numbers, because random number generation is something quite often used in our codes when we write simulation codes and all this. And there are standard libraries also, but you should also know that how to write your own random number generator function and try to see the difference of the quality of the random numbers generated by it. So that maybe I'll take 10-15 minutes to discuss about it in the next class before I start the references. Okay, any more questions? Okay, then thank you.